This video was produced by
What is mathematics? How's that for a question?
Well, it's simple, really. You see, it's I don't even need to say it.
Numbers. Numbers and more numbers equal
And
other numbers.
sometimes letters.
And sometimes imaginary numbers.
I study networks. So picture an airline map where you have, say, one dot for each city and one line representing a flight between those cities. Right? That's what I mean by a network. And I study ways of chopping them up into little pieces.
So you study systems?
Well, yeah, but we can narrow down the kind of systems I study.
Okay.
Right?
I
So
can't.
yeah, that particular kind of system where Anka mentioned dots and lines. So you have, in my example, the dots are the cities and the lines are the airline paths. That kind of diagram is called a graph.
So you're a professional connector of the daughters?
Yes.
Okay.
Yes. I do dot to dot for a living. Math, the real thing, what mathematicians do, is a combination of art and science, and beauty, and it's about understanding the reasoning behind things. It's actually like the exact opposite of memorizing rules and applying formulas. It's discovering what the rules are and what the formulas are, right? So mathematicians don't really compute. And number theory starts with, I mean, you're nothing in math unless you have theory after your name, right? So like numbers, well, that's little kids study numbers, right? But we do number theory. Now that's the big time. So we got into class, and it was an upper level class. We were all math majors, all hardcore, serious math major types. And he's up there just lecturing what blah, 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 blah. And he goes on for like 20 minutes, just filling chalkboard after chalkboard, ceiling to floor. And he's going on, and we're all dutifully copying it down in our notes. And 20 minutes into the class, it was just one theorem that he was trying to prove. 20 minutes into the class, he stops dead, okay? And he says, oh my God, I can't believe this. This is all wrong. This is complete nonsense. Says, I completely messes up. Erases everything that he wrote and just starts over, right?
People say an apple a day keeps the doctor away. Can you live a day without a brain teaser?
Why would I want to try? I have never done the experiment. Let's
Can we get a brain teaser example?
If a hen and a half can lay an egg and a half in a day and a half.
Oh no, you've already lost me.
If a hen and a half can lay an egg and a half in a day and a half, okay, how long does it take 7 hens to lay 7 eggs? This has great emotional resonance for me. I was kidding about my father and the dot-to-dot puzzles, okay? But he did give me this puzzle when I was a kid and refused to tell me how to do it. Yeah, so my first book was about something called the Monty Hall problem. Now this actually has nothing to do with my main research, which is about cutting up graphs in clever ways. My love of brain teasers, there's a very famous brain teaser called the Monty Hall problem, and this is named after a game show from the 1970s. The host of the show was actually named Monty Hall. That's not a made-up thing. Yes, hard to believe. And apparently that was his real name. that was not a stage name, okay? He's still alive, living in Kansas, come to think of it. Funny coincidence. But anyway, this was a problem that was inspired by a game show. And the problem is this, and this actually maybe if you have not heard this problem before, maybe you would enjoy thinking about this. You picture that you're on a game show, okay? And you're shown 3 doors, and you're told that behind one of the doors is a car, okay? And behind the other 2 doors are goats, okay? Literally goats, bad, animals. And on the game show, yes, there were literally goats behind the doors. And the game is this. Oh, my book. Yes. Yeah, this is more impressive if it has the book jacket on it. But
You should always switch.
Should always switch.
Why?
Statistically, it won't make you win, but you have a better chance. Because people think that you have a 50% chance in the end too, but really in the original choice when you pick the first door, there's 2 other ones. That gives you a 33% chance to get the first one, and then a 66% chance. Even if you take that second door away, you still have that original 66%.
Do you guys want to switch chairs?
Boom!
Yeah, the reason now, so this is a problem that came up on the game show. It actually existed before the game show, but the reason it's such an interesting problem is that nearly everyone says, and this includes most mathematicians, nearly everyone says that it just doesn't make a difference, right? The point is, after Monty reveals a door, it's a 50-50 chance, right? You have 2 doors left. Okay, so what possible difference could it make? It's a coin toss, okay? And that's what most people say. Now, prime numbers play a very special role in mathematics because they're basically the atoms out of which numbers are made, right? So water is H2O, right? 2 atoms of hydrogen, 1 atom of oxygen. Well, the prime numbers are the atoms out of which numbers are made. So just like in chemistry, if you want to understand a substance, one thing you might do is try to figure out the atoms it's made of. If you're studying numbers, you might want to understand the components out of which those numbers are made. But as it happens, the specific graphs that I study, these Platonic graphs that are associated to prime numbers in an interesting way, are examples of Cayley graphs. And a lot of this machinery that Cayley invented turns out not to be so useful for what he was working on, but it was fantastically useful in other areas. And it's kind of interesting, I think, just because this is a pattern that seems to repeat itself over and over again, that mathematical machinery that's invented for one purpose or to solve one problem ends up being fantastically useful in other areas.
I learned that sexy prime numbers exist. It's an absolute thing.
I'm gonna be looking for it.
Absolutely.
Can you say again what they are?
Sexy.